third and final video on correlation. If you've not yet watched the previous two videos, please go back and do so, so that way you have adequate background for the information we're going to cover here. So we know that we can use our respective data to calculate correlation coefficients to determine the strength of the relationship between two different continuous numerical variables. And the closer that R is to either 1 or -1, the stronger the relationship is. Now, in addition to determining how strong the relationship is between two variables, we also would like to know if that relationship is significant or not. So in order to do so, we go back to our hypothesis testing framework, in that our null hypothesis is that R equals 0, which would be that there's no relationship between these two variables. And our alternative hypothesis is that there is a relationship and that R does not equal 0. And so what we'll do in this video is learn how to test if a correlation coefficient is likely to occur given there's no relationship between these two variables, i.e., is there some type of a significant relationship between the variables that we're assessing. In order to do so, we're going to use the t-distribution. So we're going back a few lectures using that sampling distribution that we are familiar with, and we are going to use the formula here on the right. And one thing that you'll note here is that we are going to use our sample sizes, our correlation coefficient, and we're also going to use R squared. R squared is called the coefficient of determination. We're going to briefly talk about that today, but we'll talk more about that when we get into linear regression in the next set of videos. Now, something important for this particular test of significance of our correlation coefficient is that the degrees of freedom equals n minus 2. So for our t-tests, our degrees of freedom were n minus 1. Here, our degrees of freedom are n minus 2. So it's important to kind of keep track of these things. So we can go back to our length and weight data from the previous video's example, and we know that the correlation coefficient is 0.46, so we've got a positive correlation. It seems to be moderately strong, not super strong, and we're interested in testing if the correlation is significant or not. Well, before we go ahead and answer this question, first question is to answer how strong that relationship is. And we can use the coefficient of determination in which to do so, R squared. So we simply take our correlation coefficient R and we square that value to get our coefficient of determination. In this case, it ends up being 0.212. Now what this number indicates to us is that the variance in the data pairs that of body weight and length that is explained by the correlation or the relationship of these two variables only accounts for 21.2%. So if we think about this, 80% about of the variance in our data pairs is not explained by this relationship. So it might suggest this relationship, while it's positive, isn't super strong. So the strength of the relationship we would classify maybe as low to moderate. But this is relatively subjective because there's no thresholds here that we're defining a strong versus a moderate versus a low relationship strength. So we're going to use this formula here to determine if this relationship is significant or not. This will give us a defining number for p-value in which to then assess the strength of this relationship when it comes to significance. So before we do so, we need to define our significance level. Again, for our particular course, we're going to define this by default at 0.05 unless we're told otherwise. We need information on the sample size. We've got 10 data pairs. Again, n is relating to the number of data pairs, not the total number of data points. And then we need to determine if we have a one-tailed or a two-tailed test. Now, we don't necessarily have anything in the problem indicating to us that we should be conducting a one-tailed test, so we're going to use a two-tailed test for this, and that's going to affect our critical value that we're testing against. So we can go through and we can put in our information into the formula on the top right here, and we can calculate out what t is. In this particular case, it's 1.465, so this is our test statistic. We're then going to take this and compare it to our critical value. Now we've done this pretty extensively throughout the semester, including using the t-table. So we're not going to do this in this video, but we'll go over some examples in class. And so our critical value for this example is 2.306. And this is again based on our t-table. For a two-tailed test, the significance level of 0.05. So what we find is that our t-value is less than our critical value. So we know that this means that we need to fail to reject our null hypothesis. We don't have enough support to indicate that there's any kind of significant correlation here. So even though there is a relationship, it's low to moderate, it's not a significant correlation between these two variables. Now, something important to note is that a relationship can be strong, meaning that the correlation coefficient is high, but not significant. And conversely, a relationship could be relatively weak with a low R value, but it could be significant. And the key here is going to be sample size. Now, for a small sample, it could be potential in which we have a relatively strong correlation just by random chance. And so it's important that we're paying attention to our sample sizes before we jump to any conclusions or make any inferences about our data set. Because one of the keys here is that we want to avoid type 1 error as well as a type 2 error. If we think about a large sample size, oftentimes we can achieve significance because of that large sample size, but we might not have a particularly strong relationship here. And so paying attention both to the strength of the relationships as well as the significance is going to be important moving forward when we make decisions about how important that relationship is when it comes to different biological processes. So this brings us to the end of the videos for correlation. Some important things that you should know are the main differences between correlation and regression, and we'll be covering regression to the next set of videos. What the correlation coefficient and coefficient of determination indicate, the strength of association and how much variance is explained by that association of those two variables, how to calculate the correlation coefficient and coefficient of determination, R and R squared, and then how to determine if a correlation is significant. In addition to these videos, use the text as a resource for this particular video, in particular section 13.2.1 and practice exercises 13.1 to 13.3. Moving forward, we'll begin talking about linear regression, which we'll be able to use to assess cause and effect relationships between continuous numerical variables.